Alright, welcome back everybody with optics. Today we are starting thin lenses and primarily talking about converging lenses. Alright, here we go. Here's some examples of thin lenses. As we can see, we have these glasses here that are very thin lenses, cameras that have thin lenses, microscopes that have thin lenses, and so on. Some examples. Alright, let's move. Thin lenses. Thin lenses are lenses with thickness small compared to the radius of curvature. They refract light from to form images by bending rays at their surface. So there's two types. We've talked about this: convex, converging lenses. Thicker in the middle, bends light rays toward a focal point. Okay, so here we have the converging lenses. Can form real or virtual images depending on the object position. Then we have concave or diverging lenses. Thinner in the middle, bends light away from a focal point, always forms virtual, upright, and reduced images. So this one's going to be a lot more simple, as you see as we do examples in the future or momentarily. But we're going to start with learning about converging lenses today, and we'll see how we do. All right, so good demo video. Watch it if you can. All right, here we go. Thin lenses converging between curvature and focal point. Okay, so this is what we're talking about when we're between the radius curvature and the focal point. This is how it's going to work. Ray 1 travels parallel to the principal axis, then refracts through the focal point on the opposite side. So parallel through here. Once it reaches here, then it's going to go through the... Oops, sorry. Not the best with my arms. Through the focal point. Good. Ray number 2 travels through the center of the lens, optical center, and continues straight without bending. So pretty similar, anyway, to last time when we learned about mirrors. We're going through the center and just goes straight through. And then we already have two pieces of information. We could draw what the image will look like. It'll look like this. But anyway, the third one, if you want to just be clear, travels toward the focal point on the opposite side, then emerges parallel to the principal axis. Okay, so it goes through the focal length. And this is usually the one I like to do. And then it's going to go like this. Okay, and it should all converge at the same place. Personally, I like to do both 1 and 3. And then I don't really do the other ones, but up to you. Things we should know about the image at this location when the object is between the curvature and the focal point. If the location of the image is beyond the curvature, or 2f, farther from the lens than the center of curvature, the size is magnified, larger than the object, it is inverted, upside down, and the type of image is real. Okay, so it is real when it is on the opposite side of the object when it comes to thin lenses. All right, moving on. Okay, looking at the diagram below of an object that is placed between the curvature and focal point, tell me A, is the image shrunk or magnified? B, is the image virtual or real? Is the image inverted or upright? Well, we can tell that it is bigger, so it is magnified. It is on the opposite side of the object, so it is real for thin lens. It is upside down, so it is inverted. Okay. Trace the following diagram to find the location of the image. Okay, so I'm just going to do 2. I'm going to go straight across and then go towards this focal point. Something like this. And then I'm going to go... Let me draw the second part again. Sorry. Something like that. And then I'm going to do focal point. Oops. Change that. Don't have the best pen thing. Focal point. Something like that. It should probably be a little bit under. And then it's going to look something like this. I would imagine it's a little bit bigger down. But it should look something like that. And yep, that's what we get. And yeah, like I was right. It should be a little bit further down because I think I drew this a little bit wrong. It should be more like that. And then it converges more like over there. But anyway, we get the idea. We get the result that we want. Okay. All right, moving on. So this one's a little different. Travels parallel. So this is when the converging is between the lens and the focal point. So we have the object right here. Okay. Travels parallel to the axis, then refracts through the focal point on the opposite side. So last time, like we talked about, we went here, and then we go towards that focal point. But we're also having the reflected part go this way. And then the second one travels through the optical center. Again, we're going straight down, but the reflected part going way back this way. And then, like last time, travels towards the focal point on the far side, then emerges parallel to that. So we're going from here, here, and then goes like that, but then reflects back this way. So we can see it, they all converge at this point over here. So whenever it's between the focal point and the lens, we have the location on the same size, as we can see. It is magnified, it is bigger, it is upright. It is a virtual image because it is on the same size as the object. Okay. And this is the other one, the last one. This is when it's beyond the curvature, past curvature. Ray number 1 travels parallel to parallel axis, then refracts through the focal point. So parallel, then goes towards the focal point. Then ray 2 travels through the optical center of the lens. So we're just going kind of straight through. That's the one in blue. And then travels toward the focal point on the opposite side, then emerges parallel. Okay, so then we have boom, and then boom. And then it all converges right here. So this is for past curvature. As we can see, the size is reduced. The magnification is smaller. The orientation is inverted. And it's a real image because it's on the opposite side. All right, so that's how you draw and understand where the object is for each of these. We're going to do some conceptual questions now. So what type of image does a converging lens create when the object is placed beyond the curvature? There's a few things you can do. You could kind of memorize what's happening here for these situations. Or you can kind of like draw it out and kind of think for yourself. But once you start doing a few of these, you start to understand how it all works. Does a converging lens create when the object is placed beyond the curvature? So we just did this one. This kind of tells us all what it is right now. But, you can kind of draw it again and see. But the answer is going to be real, inverted, and reduced. Okay, moving on. When an object is placed between F and the lens, the image is formed by a converging lens is blank. Again, we talked about this. This one right here. So then we know the answer again is going to be virtual, upright, and magnified. So it's going to be B. 18. Again, you can go back. If a converging lens forms a real and inverted image, where must the object be located? Forms a real and inverted. So it's on the other side. It's upside down. Real inverted image, where must the object be located? Beyond F. Okay. So we just talked about these, and hopefully you remember and can apply your knowledge. Oh, what happens to the image size when an object moves from beyond the curvature to just beyond F? So remember, when it goes beyond, so it should be getting a bit bigger, so the image is getting larger and larger. Okay, the further out it goes, it's getting smaller and smaller, as we talked about. Which lens would create a magnified upright image? We kind of talked about this too. A converging lens with the object beyond the curvature? No. A converging lens with the object between F and the lens? A converging lens with the object at curvature? No. No converging lens can be produced? Nope. It's going to be B. A converging lens with the object between F and the lens. And we just kind of talked about this, so look back at the video if you need kind of an explanation why. But here's kind of like a summary of where the object and image is, and the size, and orientation, and type, depending on what you're looking for. So this might help to memorize, but this should at least be used as some kind of guide to help you answer these kind of questions. All right, so a little bit tricky because you do a little bit have to memorize here, but anyway, hopefully it was all right. All right, thanks for watching, everybody. Next time we're going to be talking about diverging lenses, which is actually quite a bit simpler. So hope to see you with that. Thanks for watching, everyone. Bye.